Okay, welcome back to our problem solving series with 2, question 1. So in this question, we are going to use the notions on implicit differentiation which we studied in our previous video in order to solve or to differentiate this question below, that is to find the y and the x. So first of all, let's recall the different steps we enlisted in order to use implicit differentiation to find the y and the x. What was our first step? Our first step was to ensure we have an equation in terms of x and y. And observing this question, we already see or we already know that this question is an equation in terms of x and y. Moving on to our second step. What did the second step ask us to do? It asks us to apply or to derive both sides, to apply the differentiation or the derivative with respect to x on both sides of the equation, that is the left hand side and the right hand side. So let's apply it. D on the x of our left hand side, sine of xy plus x squared y equal to d on the x of y cubed plus cos of x. So opening the bracket, we have d on the x of sine xy plus d on the x of x squared y equal to d on the x of y cubed plus d on the x of cos x. So in this question, we observe that there are 4 different terms in which we need to apply the differentiation, or 4 different terms to differentiate. Our first term being sine of xy, second term x squared y, third term y cubed, and fourth term cos x. So we're going to take term by term and apply differentiation. So let's start with our first term, sine of xy. So when we observe this, what do we note? The first thing we notice is that this is a function of a function, with our first function xy and our second function the sine function. And every time we have a question or an equation which is a function of another function, the first rule or the first thing that comes to our mind is to use the chain rule. So first of all, what does the chain rule state? Let's recall the chain rule. It states that the derivative with respect to x of a function in terms of another function, that is f of g of x, is going to be equal to f prime of g of x times g prime of x. So the first thing we need to do in this case is to identify our g of x and our f of x. So we'll say let g, we'll not say let g of x, we'll just say let g be the function. Why do we say g? Because g of x is a function in terms of x, whereas our function in this case is a function in terms of x and y. So we could still say let g of x comma y be equal to xy. This implies and let f of u be equal to sine u. So we're going to start first of all by finding f prime of u. F prime of u then is equal to the derivative with respect to u of the function sine u, which gives us, recalling the video on the derivative of trigonometric functions, it was well proven and well stated that the derivative of our function sine x, or sine u in this case, is equal to cos u. So moving on to our next term, that is substituting, let u, not letting, u equal to g of x, then implies that f prime of u, which is equal to f prime of g of x, is the function cos of g of x, which is cos of xy. So we are not yet done with our complete differentiation. We have found our first term f prime of g of x. We still need to find our second term g prime of x. So g of x is the function xy, and what we notice is that g of x is a function which is represented by the product of 2 different functions, with our first function being x and our second function being y. And every time we have a function which is the product of two other functions, the first rule which comes to our mind is the product rule. So what does the product rule state again? Let's recall the formula. The product rule states that the derivative with respect to x of a function uv is equal to u dv plus v du. So in this case, we then need to identify our u and our v. Let u be equal to x. It implies that u prime, which is the derivative with respect to x of u, which is the derivative with respect to x of x, gives us the function 1. Let v be equal to y. This implies that v prime, which is the derivative with respect to x of y, is equal to the derivative with respect to y, derivative dy on the x times derivative of y with respect to x, with respect to y, with respect to y. This formula was well stated in the previous video when we were working on derivative of implicit functions. It was well stated that the derivative with respect to x of a function f of y is equal to dy on the x times the derivative of that function with respect to y. So in this case, our function f of y is the function y. So the derivative with respect to x of y gives us dy on the x times d of our function y with respect to y, which gives us dy on the x times 1. So we can then conclude that g prime of x, which is u dv, what is u? X times dv is dy on the x plus rv y times du, which is 1. So this gives us x dy on the x plus y. So we have calculated our g prime of x and we have calculated our f prime of g of x. So we can then calculate the derivative for our first term, which is f prime of g of x times the g prime of x. So the derivative with respect to x then of our first term, sine of xy, gives us cos of xy, that is f prime of g of x times g prime of x dy on the x plus y. Let's open our braces, leaving us with x dy on the x cos of xy plus y cos of xy. So in conclusion, for our first term, the derivative with respect to x of the function sine of xy gives us x dy on the x times the cos of xy plus y cos of xy. So this is our first equation. So we are done with deriving our first term. We are done with this derivative. So let's move on to our second derivative, the differential with respect to x of the term x squared y. The derivative with respect to x of the term x squared y. So this is our next term. The first thing we identify is that this function x squared y is still the product of two functions, with our first function being x squared and our second function being y. Knowing that it is a product of two functions, this automatically tells us that in order to perform this differentiation, we will need to use or to apply the product rule. What does the product rule state? A product rule statement has been recalled here above, so we'll just use the same formula. So in order to do this, we first need to identify our u and our v. So we'll say let u be the function x squared. This implies that the derivative of u, or u prime, let me just write it directly. This implies that u prime is equal to the derivative with respect to x of our function x squared, which from our power rule gives us 2x. Now we let v be the function y. This implies that v prime is equal to the derivative of y with respect to x, which gives us dy on the x. This then implies that the derivative with respect to x of our function x squared y is u dv plus v du. What is our u? X squared times dv dy on the x plus vy times du 2x, leaving us with x squared dy on the x plus 2x. So we can then conclude that the derivative of our second term, x squared, or our second term, sorry, gives us x squared dy on the x plus 2xy. We call this equation 2. Let's move on to our third term. What does our third term ask us to find? In our third term, we are asked to derive with respect to x the term y to the power 3 or y cubed. So let's work on that. The derivative with respect to x of our function y cubed is equal to the derivative of y with respect to x times the derivative of our function, which is in terms of y with respect to y. This is just an application of this formula, which was well stated and well explained in the previous video. So let's move directly to finding this term. This gives us dy on the x times the derivative of y cubed with respect to y. We can directly apply the power rule, which gives us 3y to the 3 minus 1, which gives us 3y squared dy on the x. We can then conclude that the derivative with respect to x of our term y cubed gives us 3y squared dy on the x. We label this equation 3. Let's move on to the fourth term of our equation. This fourth term tells us to differentiate the function cos x. Recalling the derivative of trigonometric functions, we notice that, or we recall that the derivative with respect to x of the function cos x gives us negative sine x. We call this our equation 4. So we have calculated, or we have already determined our 4 different terms. So all what is remaining for us to do is to substitute these different terms in our general equation. That is our first term plus our second term equals to our third term plus our fourth term. So let's do that. What's our first term? Our first term is x dy on the x cos xy, x dy on the x cos xy plus y cos xy plus y plus y. Let me check. Yes, plus y cos xy. So okay, plus y cos xy plus our second term, which is x squared dy on the x plus 2xy, x squared dy on the x plus 2xy equal to our third term, which is 3y squared dy on the x plus our fourth term, which is minus sine x. So after completing this step, our next step then is to use algebraic methods or algebraic identities and algebraic methods in general to make dy on the x, or to find dy on the x. The first thing we need to do in this case is make dy on the x the subject of the formula. How do we make dy on the x the subject of the formula? This can be done by moving all terms which contain dy on the x to one side. So let's move it to our left hand side. Our first term is x dy on the x cos xy. This term contains, so we'll leave it on this side, x squared dy on the x. So we're done with this term. This term also contains, moving it to the opposite side, turns to a minus y squared dy on the x. Those are all the terms which contain dy on the x. Now move all the terms without dy on the x to the other side. We start with this term, negative y cos xy. The next term, minus 2xy. The last term, minus sine x. We can then factorize dy on the x, leaving us with x cos xy plus x squared minus 3y squared equal to minus, let's factorize minus out, y cos xy plus 2xy plus sine x. This leaves us with dy on the x being equal to minus in bracket y cos xy plus 2xy plus sine x, or divided by x cos xy plus x squared minus 3y squared. So we can then conclude, therefore, the derivative of y with respect to x, that is dy on the x, gives us the function negative in bracket y cos xy plus 2xy plus sine x bracket close, all divided by x cos xy plus x squared minus 3y squared. We box or we enclose our answers. So in this question, although the question seemed it looked a bit complicated from the beginning, using our steps which we established in the previous video on the differentiation of implicit functions, we're able to carefully differentiate this function, that is implicitly differentiate each term. After differentiating each term, we're able to make dy on the x the subject of the formula in order to find dy on the x. So after finding this, we're left with dy on the x being the function negative in bracket, we have y cos xy plus 2xy plus sine x bracket close, all divided by x cos xy plus x squared plus, is this plus? Yes, minus 3y squared. So thank you for watching this video. See you on the next video. Bye.